Why are AI data centers straining America's power grid? Today we're taking a bit of a cinematic journey right behind your screen. We're going to pull back the curtain on the actual physical reality of the cloud. Because, well, the seamless magic of artificial intelligence, it isn't just happening in the ether. It's happening firmly on the ground, behind the hum of these massive nighttime substations and giant cooling towers. And let me tell you, it is drawing an absolutely staggering amount of power. Okay, let's dive right into this. I think it's time we finally shattered the illusion that AI is just this weightless software floating around in the sky. When you shoot a prompt over to ChatGPT, the answer feels instant, right? It feels basically cost-free. But underneath all that digital magic is a massive, highly energy-intensive physical infrastructure. We're not talking about those modest little server closets from the early internet days. No, we're talking about a rapidly expanding network of industrial fortresses spanning millions of square feet, fundamentally altering our physical landscape.
It's a crazy contrast. On one hand, you've got this illusion of lightweight apps right there in your pocket. But the reality, to actually make those apps work, we're building sprawling warehouses packed with thousands and thousands of GPUs. These hyperscale facilities are popping up almost overnight, often in marginalized or rural areas. And get this, they operate at power densities over 100 times that of a normal office building. We're talking about glowing halls of server racks pulling as much power as an entire small town, all concentrated in just one spot.
To really put that into perspective, just think about the number 100,000. One single modern AI data center can consume as much electricity as 100,000 households. I mean, imagine an entire city's worth of power demand just suddenly dropping onto the local grid overnight. This isn't the slow, predictable population growth that utility companies are used to planning for. This is an immediate, massive spike in concentrated energy demand that is quite literally putting our city lights under strain. Now, what's really fascinating about this is the sheer disparity in growth. According to the International Energy Agency, baseline global electricity demand is growing at around 3%. But data center electricity demand, that jumped about 17% in a single year. And those sites specifically focused on AI, they're growing even faster than that. Since the US currently handles about 54% of total global hyperscale capacity, it means the epicenter of this massive energy surge is happening right here on the American grid. So this creates a really severe local bottleneck. Say a tech company builds a new AI campus and they want hundreds of megawatts right now. Well, the physical grid can't just flip a switch. It takes years of heavy construction to deliver that kind of capacity. We're talking years to build robust new transmission lines, years to get heavy-duty transformers manufactured and installed, and years to actually bring new power generation online. In fact, the North American Electric Reliability Corporation recently called data centers the single largest driver of projected demand growth. They even noted a recent event where roughly 1,500 megawatts of data center load disconnected all at once. It's just wild. So how are we actually keeping the lights blinking on all those servers today? Well, despite a lot of corporate clean energy pledges, here's the reality of US data center power right now. About 40% comes from natural gas, 24% from renewables, 20% from nuclear, and 15% still comes from coal. The immediate demand is so intense right now, the power utility companies are actually having to slow down or even reverse the retirement of old peaking power plants. These are facilities usually held in reserve just for extreme situations, like a massive summer heat wave. But obsolete coal plants are literally being forced back into regular service just to keep up with the data center boom. Now, you might be thinking, but surely the tech is getting more efficient, right? And yes, it is. But here we run straight into the Jevons paradox. While the hardware itself is getting way more energy efficient, the workloads are getting exponentially heavier, especially those autonomous agent workloads that do multi-step tasks for you. Researchers found that a smaller AI task might use around 114 joules of energy. But if you query a massive AI model, that can use up to 6,700 joules. To put that into perspective, that's roughly the same as running your kitchen microwave for 8 seconds, just for one single response. Multiply that by billions of queries from more and more users worldwide, and total energy consumption is absolutely skyrocketing. All of this culminates in one staggering projection from the IEA. 945 terawatt hours. They project that global data center electricity consumption will roughly double to hit that number by 2030. That is a massive 15% growth year over year. And according to the US Department of Energy, To handle this kind of influx, the grid is going to need everything from new nuclear energy and next-gen geothermal to direct physical connections built strictly between data centers and power plants.
So here's the crucial point, right? Who actually pays for all this rapid grid expansion? The local economic impact is becoming a pretty major point of debate. For example, a recent audit in Virginia projected that everyday residential customers could see their monthly power bills go up by $14 to $37 by 2040, essentially subsidizing these massive grid upgrades. And because of concerns over things like rising bills, water usage, and land impact, local grassroots opposition has actually blocked or delayed roughly $64 billion in data center projects recently. It's a very real on-the-ground tension between rapid technological progress and protecting vital community resources. Which leaves us with this fundamental question. As we push the boundaries of what machine learning can do, we're basically forcing the physical world to keep pace with the digital one. So what's the real trade-off here? Are we going to choose having more and more powerful AI instantly available in our pockets? Or do we prioritize a reliable grid that can still keep utility prices and reliability intact for everyday people? It's a huge question, and honestly, it's one we're all going to have to answer very, very soon.
If you enjoyed this video, please like, comment, and subscribe for more AI and technology content. Thanks for watching.